If you look up at the night sky, you'll see stars, the moon, and sometimes planets like Venus or Mars shining as bright points of light. But what if the sky was crossed by a set of giant rings, much like Saturn's? The sight would be surreal, a bright arc on the horizon during the day and a celestial light show at night. However, beyond the visual spectacle, the fact that Earth had rings like Saturn would change our lives in many other ways. Saturn's rings are made up of billions of small particles of ice and rock, orbiting the planet in a remarkably organized structure. If Earth had rings, they would likely be made of similar materials, with ice and dust reflecting sunlight. But unlike Saturn, which has an immense gravitational field, Earth is much smaller, and its rings would be closer to us, drastically altering the way we perceive the sky. To understand what this new world would be like, let's first explore how Saturn's rings are structured. Saturn's rings are the most extensive ring system of any planet in the solar system, consisting mainly of chunks of ice and rock, with sizes ranging from microscopic particles to blocks several meters across. The rings are mostly composed of ice, which gives them a bright appearance as they reflect a significant amount of sunlight. Although the rings often appear white or yellowish, they contain color variations due to impurities and differences in the composition of the ice and dust. The rings reflect more than 80% of sunlight, making them visible through telescopes from Earth. Saturn's rings are divided into several main sections labeled with letters A, B, C, D, E, F, and G. The densest and brightest rings are A and B, while the thinner, fainter rings like C and F are less visible. The Cassini division is a prominent gap between the A and B rings, spanning about 4,800 kilometers in width. Despite appearing solid and robust, Saturn's rings are extremely thin relative to their vast expanse. They extend up to 282,000 kilometers, but their thickness varies from just 10 meters to a few hundred meters. The exact origin and age of the rings are still debated. They are estimated to be between 100 million and 400 million years old, meaning they might be relatively young in astronomical terms. Some scientists believe they could have formed from a destroyed moon. Now that we have a better understanding of our neighbor Saturn, let's use this as a basis for imagining what Earth's rings might be like. If you were in a city near the equator, the rings would appear as a nearly straight line in the sky, cutting across the horizon. In higher latitudes, such as in the United States or Europe, the rings would curve into grand arcs, rising and falling across the horizon, ever present. In comparison, Saturn, despite being one of the most impressive planets in the solar system, could never offer such a personal view to its inhabitants. Its moons are small, and its conditions are too hostile for life. Earth, with its rings, would be the perfect home to admire such an awe-inspiring and accessible natural phenomenon. The rings, reflecting part of the sunlight back into space, could cool certain parts of the Earth. Areas directly beneath the rings, like those near the equator, would receive less sunlight during the day. This would function as a kind of natural air conditioner, potentially keeping the climate more temperate. Cities that currently suffer from extreme heat, such as those in equatorial regions, might experience milder temperatures, while others at higher latitudes may not notice as much of an effect. On the flip side, this could create entirely new and unexpected weather patterns. The sun would no longer have the same clear path to heat all corners of the planet as it does today. At certain times of the year, Earth would pass through the shadow of the rings, resulting in a phenomenon similar to a partial eclipse, where sunlight would be blocked in some regions. This could bring about a kind of ring winter, a period of cooler weather even during the summer months. In cities, especially in large metropolitan areas, light pollution already makes it difficult to see the stars. This doesn't mean that there would be no dark nights anywhere, but they would certainly become much less common. The experience of observing a truly dark, starry sky, as ancient humans once did, would become a rare event. In a way, the sky would be always lit, even in the most remote places. For humans, this constant shift in illumination could directly affect how we sleep and even how we live. Animal life, particularly nocturnal species, would also feel the impact. Animals that rely on total darkness to hunt or hide would be exposed to a new reality. The circadian rhythm, which regulates sleep in many animals and humans, could be disrupted, leading to unexpected consequences for our health and behavior. If Earth had rings since its formation, they would have undoubtedly shaped the development of our civilizations. The sight of the rings in the sky would be so constant and imposing that many ancient cultures would likely have created myths and stories centered around them. Imagine the pyramids of Egypt, the Mayan ruins, or Mesopotamian civilizations, with their skies adorned by these gigantic arcs. The cultural impact would be profound. Religions might have attributed divine meanings to the rings, perhaps seeing them as a kind of heavenly crown for Earth. Monuments and temples could have been constructed in alignment with the rings, and festivals might have been organized based on their shadows and movements across the sky. Throughout history, cultures have always been inspired by the heavens. The presence of the rings would have only amplified this fascination. Our navigation would also be fundamentally different. Today, we use the stars and the position of the sun to orient ourselves, but the rings could provide a constant visual reference, offering a simple and effective way to determine directions and positions. Maritime exploration might have started much earlier, as the always visible rings could serve as guides over the open ocean, where previously there was only darkness. The rings wouldn't just be a spectacle in the sky. For future space exploration, they would pose a significant challenge. Just as engineers who designed missions to Saturn had to account for the rings when sending probes around the planet, missions from Earth would need to carefully plan how to navigate through this field of space debris. Launching satellites and spacecraft through the rings would be a risky task. The rings, composed of ice and rock particles, would be moving at high speeds. Any object attempting to pass through them would risk being hit by these fragments. Our communication systems, which today rely on satellites in geostationary orbit, would need to be reconsidered, as the rings would occupy precisely this region. To stay connected, we would need to find creative solutions to either bypass the rings or even use them to our advantage. This brings to mind the real challenges we face with Saturn's rings and even with space exploration around Jupiter. The probes sent to these planets must be meticulously planned to avoid dense regions of space debris that could damage them. If Earth had rings, mission planning would become even more complex and fascinating. Just as the moon affects Earth's tides, the rings could also influence the movement of the oceans. With this additional gravitational force, tidal patterns would be different. Instead of the regular tides we know, we would experience more intense and complex tides, especially during certain times of the year when the rings align in a particular way with the sun and moon. A real and interesting example of how something similar might happen is with our own moon. When the moon passes between the sun and Earth, we experience solar eclipses. While Earth's rings would never fully cover the sun, their moving shadow would create a similar, though more prolonged and less extreme, effect. The Earth's climate would constantly shift between light and shadow, resulting in an even more complex cycle of seasons than we currently have. If you enjoyed this content, be sure to subscribe to the channel and activate notifications to learn more about science and the universe we live in. See you in the next video.